So this video is the multiple choice questions for the AP Physics exam for the topic of Newton's laws. So for the first question, a person standing on a horizontal floor feels two forces: the downward pull of gravity, the weight of the person, and the upward supporting normal force from the floor. Okay, so these two forces A have equal magnitude and form an action reaction pair, or B have equal magnitudes but do not form an action reaction pair, or unequal magnitudes and form an action reaction pair, or unequal magnitude but do not form an action reaction pair, or E, none of the above. So as you can see, this is the person. Because the person is not accelerating, the net force is 0, right? Which means that the upward normal force from the floor is equal to the downward gravitational force. So N is equal to W. But although these two forces have equal magnitudes, they do not form an action reaction pair because they are acting on the same object, which is the person. Okay. And this is because the forces of action and reaction pair always act on different objects. So for the second question, a person who weighs 800 newtons steps onto a scale that is on the floor of an elevator car. Okay, so if the elevator accelerates upward at a rate of 5 meters per second square, then what will the scale read? So this is the free body diagram of the person. So the person is accelerating upwards, and the person exerts a downward force on the scale, and the scale pushes up on the person with an equal and opposite force N. Okay, so the scale reading is N, which is the magnitude of the normal force. So if we apply Newton's second law along this direction, we get N minus W is equal to MA. So N is equal to W plus MA. W is 800 newtons, and the mass is 800 newtons over the gravitational acceleration 10 meters per second square. And this gives the reading of the scale is 1200 newtons. So the answer is D. So for question 3, a frictionless inclined plane of length 20 meters, so this length here is 20 meters, has a maximum vertical height of 5 meters, okay? So if an object of mass 2 kilograms is placed on the plane, which of the following best approximates the net force it feels? So as you can see, if we take the x-axis along this surface and the y-axis here, then sigma Fy is equal to 0. So the normal force is equal to mg cosine theta. And sigma Fx is not equal to 0, it is equal to ma, because there isn't any other force in this direction that can balance this force. So this force here, mg sine theta, is the net force that the object feels on the inclined plane. So it is the component of the gravitational force that is parallel to the ramp, okay? And its magnitude is equal to 2 times 10 sine theta, which is 5 over 20, so it's equal to 5 newtons, and so the answer is A. So for question 4, a 20 Newton block is being pushed across a horizontal table by an 18 Newton force. Okay, so if the coefficient of kinetic friction between the block and the table is 0.4, so mu k is equal to 0.4, find the acceleration of the block. So as you can see, the net force along the y direction is 0, so N minus W is equal to 0, so the normal force is equal to the weight. And the net force along the x direction is equal to ma, because the object is accelerating, okay? So the net force along the x direction is the applied force minus the kinetic frictional force, so F applied minus mu kn, and N is equal to W. So we substitute. The applied force is 18 Newton minus 0.4 times 20 Newton. So the net force is equal to 10 newtons, okay? And so the acceleration is equal to sigma fx over m, and m is found from the weights, so it is 20 newtons over 10 meter per second square, and this gives the acceleration is 5 meter per second square, so the answer is C. So for question 5, the coefficient of static friction between a box and a ramp is 0.5. The ramp's inclined angle is 30 degrees. So if the box is placed at rest on the ramp, the box will either accelerate down the ramp or accelerate briefly down the ramp but then slow down and stop, or move with constant velocity down the ramp, or not move, or cannot be determined from the information given. So the net force along the y-axis here is 0, so the normal force is equal to mg cosine theta. So at the verge of slipping, the force down the ramp, which is mg sine theta, will be equal to the maximum static frictional force Fs max, and Fs max is equal to mu Sn, so it is equal to mu s mg cosine theta. So if mg sine theta is greater than Fs max, then there will be a net force down the ramp, and the block will accelerate down, okay? So the question is if mg sine theta is greater than mu s mg cosine theta, which means if sine theta is greater than mu s cosine theta, and theta is equal to 30, so sine theta is half, and mu s cosine theta is less than half, so which means the object will accelerate down the ramp, so the answer is A. So for question 6, assuming a frictionless massless pulley, determine the acceleration of the blocks once they are released from rest. So if we draw the, the free body diagram for each block, then for this one, T minus mg is equal positive ma because the acceleration is upwards. And for this mass, T minus mg is equal to minus ma, okay, because the acceleration is in the negative direction. So if we multiply this equation by minus 1 and we add these two equations, we get A is equal to m minus m over m plus mg, which is E. So for question 7, if all of the forces acting on an object balance so that the net force is 0, then the object must be at rest, or the object's speed will decrease, or the object will follow a parabolic trajectory, or the object's direction of motion can change but not its speed, or none of the above. And the answer is E. And this is because if the net force is 0, it means the acceleration is 0, and 0 acceleration means the velocity does not change in magnitude nor in direction. So for question 8, a block of mass m is at rest on a frictionless horizontal table placed in a laboratory on the surface of the Earth, and an identical block is at rest on a frictionless horizontal table placed on the surface of the Moon. So let F be the net force necessary to give the earth-bound block an acceleration of A across the table. Then given that the gravitational acceleration of the Moon is 1/6 of the gravitational acceleration of the Earth, then the force necessary to give the moon-bound block the same acceleration across the table is the answer is D. And this is because the horizontal motion across the frictionless table is not affected by the vertical gravitational acceleration, okay? So it would take as much force to accelerate the block across the table on Earth as it would on the Moon. So the answer is D, the same force F, okay? But note here that if friction were taken into account, then the smaller weight of the block on the Moon would imply a smaller normal force by the table, and therefore a smaller frictional force. And so if friction is taken into account, then less force would be needed on the Moon to move the block. So for question 9, a crate of mass 100 kg is at rest on a horizontal floor the coefficient of static friction is 0.4 and of kinetic friction is 0.3. So a force of magnitude of 344 Newton is then applied to the crate, parallel to the floor. So which of the following is true? So first, the crate will accelerate across the floor at 0.5 meter per second square. So let's check if the crate would move. So if the applied force is greater than the maximum static frictional force. So the maximum static frictional force is equal to mu Sn, which is equal to mu Sw, because the normal force is equal to the weight, because the net force along the y direction is 0. And this gives the maximum static frictional force 392 newtons. So the applied force is less than the maximum frictional force, which means that the crate will not move. So the answer is D. And note here that this answer, which is the static frictional force, which is the reaction force to F, as guaranteed by Newton's third law, will also have a magnitude of 344 newtons. So this statement is incorrect because the static frictional force is not the reaction to F, because F and F static, the applied force and the frictional force act on the same object, the crate, and therefore cannot form an action reaction pair. So question 10, two crates are stacked on top of each other on a horizontal floor. Crate 1 is on the bottom and crate 2 is on the top, and both crates have the same mass. So compared to the strength of the force F1 necessary to push only crate 1 at a constant speed across the floor, the strength of the force F2 necessary to push the stack at the same constant speed across the floor is greater than F1 because, and the answer is A. Which is the force of the floor on crate 1 is greater, okay? And this is because if crate 2 is on top of crate 1, then the force pushing downward on the floor would be greater, right? So the normal force exerted by the floor on crate 1 would be greater, which will then increase the frictional force. And because the frictional force is increased, this means that the force necessary to be applied to the stack to move at the same constant speed would be greater than if crate 1 is alone. So all of these remaining statements are false, okay? So here the coefficient of kinetic friction between crate 1 and the floor is greater. This is false because the coefficient of kinetic friction does not change. Only the normal force change, okay? And also here the force of kinetic friction but not the normal force on crate 1 is greater, and this is also false because the force of kinetic friction is related to the normal force on crate 1. And the coefficient of static friction is greater. Again, the coefficient does not change, but only the normal force. And this statement, the weight of crate 1 is greater, is also false because the weight remains the same. So for question 11, an object moves at constant speed in a circular path. Which of the following statements are true? So first, the velocity is constant. So this is incorrect because the velocity has constant magnitude, but it is continuously changing direction while the object moves along the circular path, okay? So this is false. The second one is the acceleration is constant. This is also false because the velocity is changing in direction. Even if its magnitude is constant, its direction is changing, which means there is a centripetal acceleration, okay? A non-zero acceleration. And the third option, the net force on the object is 0 since its speed is constant. So the object is accelerating, it has a centripetal acceleration, and this acceleration is because of a net centripetal force on the object. So the net force is not 0. So the answer is E, so none of the above. So for question 12, a 60 centimeters rope is tied to the handle of a bucket, which is then whirled in a vertical circle, okay? The mass of the bucket is 3 kilograms. So at the lowest point in its path, the tension in the rope is 50 newtons. So what is the speed of the bucket at this lowest point? So this is the free body diagram for the bucket at the lowest point, where the tension and weight are in opposite directions, and at the top the tension and the weight are in the same direction. And note here how the tension here is different than here, and also the speed of the bucket is different at the lowest point and at the top. So for this point, the net force along the radius of the circle, which is the centripetal force, is equal to TB minus mg, equal to mv square over r. Okay, so this is the centripetal acceleration. So this gives v equal to 2 meters per second, which is b. So question 13, what is the critical speed below which the rope would become slack when the bucket reaches the highest point in the circle here? Okay. So at the top here, the net force that provides the centripetal force is T plus mg, okay? So for the rope to avoid becoming slack, the tension must not vanish, okay? So the minimum speed for ensuring that the bucket makes it around the circle is the speed at which t becomes 0. So any speed above the speed would ensure that the bucket make it around the circle, okay? So the minimum speed is when t just becomes 0. So v is equal to square root of gr, and this gives 2.4 meters per second, which is c. So for question 14, an object moves at a constant speed in circular path of radius r at a rate of 1 revolution per second, okay? So it means the speed is 2 pi r meter per second. Because in 1 second it goes around one circumference of the circle. So what is its acceleration? So the answer is D. Because we substitute for v, we get 4 pi square r meter per second square. So thank you for watching. Please don't forget to like and subscribe, and see you in the next video.